Hey everyone, my name is Arnab and welcome to another video. So today we are going to solve a problem from CSES problem set called room allocation. And I specifically chosen this problem because it resembles um, or it's very much similar to many other problems that we see today with respect to scheduling. So, where you have been given n number of meetings and you ought to find the least number of meeting rooms that is required to schedule all these meetings, right? And corresponding allocation of these meetings to these meeting rooms and so on and so forth. Okay, so let's get started. So the problem description says that there is a large hotel where n customers can arrive. Each customer wants to have a single room, and what we know is customers' arrival and departure day. Two customers can stay in the same room if the departure day of the first customer is earlier than the arrival day of the second customer. What is the minimum number of rooms that are needed to accommodate all the customers, and how can we allocate the room? So that's the problem statement. Okay. The input looks like this, where we have n number of customers. Following in line describes each customer's arrival and departure day. What we should print is the minimum number of rooms that are required and how would you allocate the rooms to the customers. Okay. Okay, so let's try to understand uh, and trace this on a given input. Oops. Uh, okay, so if you see, we have some customers and their corresponding arrival time and departure time, and we have the output. So where we can see that customer 1 has come on day 1 and has left on day 2, customer 2 on day 2 and left on day 4, and customer 3 has come on day 4 and left on day 4. So if we try to just visualize this, um, so for the first customer, he has come on day 1 and has left on day 2. For the second customer, he has come on day 2 and has left on day 4. And the third customer has come on day 4 and has left on day 4 itself, right? Okay. So these are the three customers that we have, and the output says that you would need minimum of two rooms, and the allocation of room to corresponding customer is, for customer 1 it is room number 1, customer 2 it's room number 2, and customer 3 it's room number 1. So if we also see like what's happening here is, for customer 1, when he comes, there are no room currently there at my disposal, so I'll allocate, let's say, room number 1 to them. When customer 2 comes in, we see a room. He has come on date 2, and there has already been a room number 1 has already been allotted to customer 1 on day 2. So I can't allocate room number 1 to them, so it would be a new room that we have to give, so that this is room 2. But if we see customer 3, we see that there is by that time customer 3 comes in, only room 2 has room 2 is currently taken, but room 1 is has gotten emptied by customer 1, so we can allocate safely room number 1 to them. So that's how the output resolves to. Okay. um all right, so this is the way. Let's try to understand the intuition behind how we can solve this problem. Okay. First of all, if we have all the customers in the problem statement, there's nowhere it is written that these inputs would be in a sorted order or would be of any order, right? So to create a mind map or to come up with an algorithm, let's say we sort these customers who are defined by their start and by their arrival and departure time in some in a sorted order with respect to their arrival time. Okay. Times. Okay. So by that we now have a clear vision, like these the list of customers that we have is in a sorted order with respect to their arrival time. Now just think of it like whenever a new customer is coming in, what are we doing? We are checking whether there is an already available room, okay, which has not been taken by any customer, or even if it was taken, it has already gotten vacated. Then I can safely provide that room to that new customer that is coming in. Okay. But if there is no available room, then only I should allocate a new room. Okay. So if you observe very carefully, what we are doing is on every every incoming customer, we are checking in one of our data structure whether, hey, is there any room available for disposal for that customer? If so, please allot them. And how are we doing that? We are checking whether if whatever customers that we have stored, right, they would have a already room allotted on their behalf. Okay. So we are checking if there is a customer whose whose departure time is actually lesser than or has been earlier than my current customer's arrival time, then I can see that customer, the previous customer has already vacated it, right? And we can provide that room to this new customer. So if you get a sense, what we are trying to do is we are trying to pick an element from our data structure, uh, but by giving giving a priority to the departure time element, to the departure time property of every element that is present in the data structure. So it gives me a sense that we can make use of something called as a priority queue, to be precise, a min priority queue, where we can where the comparator will be with respect to uh, departure time. And if you have two elements in the priority queue, whenever I'm seeing a new customer coming in, I would want to pick a customer, the the very first customer in that priority queue, or the the top element of that priority queue, who is having the least departure time, right? So that I can allocate that room to the new customer. And even I have, if there has been any new customers who had left post that first customer, then I can give those rooms to the later incoming customers. Okay. So what I mean is comparative with respect to departure time, and so this is the data structure that we will have, right? So for every new customer, we check if we check uh, if there is an available room. S- If yes, then allot that to the new customer. If no, then then create a new room and allot that to this new customer. Okay, as simple as that. Okay, great. So I think we can now um, jump into the solution. Okay, so before that, I let's try to so this is a greedy solution, but this is most like this is bound to work because we are always trying to prioritize the lowest departure time and allot that to the new customer coming in, right? If I have to do a complexity analysis, this would be in order of, if n is the number of customers coming in, so this would be in order of n log n for initial sort, and also while um, we are traversing each element and checking if we can allot a room to that, we will be using a priority queue, and we are doing some inserts and deletes from that priority queue. So every operation would be happening. At the end of every operation, you will be heapifying. So that takes log n, and for n, it is n log n. N customers, it is n log n. Okay. So this is effectively order of n log n. And space complexity would be space complexity, since we are using a heap, that is gonna take order of n, right? All right, so let's jump onto the solution, the code, and see them piece by piece. So at the if you focus on this main function, what we have done is taken an input n, a, and b, which is the number of customers, arrival time, and departure time of them. We have stored a we have created a class called customer, and I'll explain about that. Uh, then what we have done is, for we have taken input n, we have taken the arrival and departure time of every customer, s- created the new customer, and then we have sorted them using a custom comparator called arrival compare. Okay, so let's see how the customer class looks like. So customer class contains your id, which is where this is typically the order of elements you can consider, to maintain the order of elements. And so for customer 1, that is given in the input, it would be 1, and customer 2, it would be 2, like that. Arrival time and departure time, and the room number that they have gotten in allotted to. Initially, that would be set to -1, to give a sense that there has not been any room allocation to them. Now, once you have initialized all the customers, now we are sorting them with respect to their arrival time. And if you check this out, this would be, so we have a custom comparator which is just doing that. Like if you be on the basis of arrival time, it is checking if the arrival time is of the first one is lesser than the arrival time of the second one, then we would want to keep the order same, otherwise flip it. Now let's understand the crux on how we are allocating room. So for as we had just discussed, we are trying to maintain a priority queue with a custom comparator called priority compare. And what if I have to expand priority compare, this would also look pretty much similar to arrival compare, just that it is in a reverse way, because here we would want to give a priority to priority by saying that if I have two customers, customer A and customer B, and if customer A's departure is actually greater than customer B's departure, uh, that means I would want to flip it, right? I would want to keep the customer B at the top, correct? And that goes by by definition of any comparator that we write for priority queue. Okay, so we are returning true. Now, comes the core of this algorithm, where we are for every new customer that is coming in, we need to allot a room number to them, right? So we are checking if my priority queue is currently either empty, or if you don't basically, if you have if you are finding a element in the priority queue, or a customer who had already departed, then um, allot the same room which you have allotted to that customer who has departed. Okay, so that is that condition here. Sorry, that is that condition in the else part. But the first condition is when if it's the first element that is coming, straight away you have to allot a room. So if my priority is empty, then I have to give them room number 1. Or if I see that, hey, there is no room that is currently available in disposal for that customer. Okay, so there also we need to create a new room and provide it to them. And if you try to create a mind map, you'll see every time that would actually be dependent on the priority queue size that we currently have here. Whenever we need to in allot a new room to that new customer coming in. So with that, all my customers will get allotted a allotted rooms, and I'm making mm, use of a vector where we are basically all right. So here by this, I would have all these customers allotted their uh, room allotted a room number. Okay, and one key thing I forgot to explain is this. So if you have allotted for a new customer that is coming in, if you have allotted a room from an existing pool of rooms, you would remove that older customer, right? So this is that part where you are popping that older element and pushing that new customer with the new room number with that room number. So this can be in initial order of these customer list that we had initially initialized as in an initial order of order of inputs, but we need a order where and we have given a room number to each of them. So this for loop is used to just set these customers in their appropriate places in the final output. So if you see this customer room numbers is doing that, and so for we are traversing over that existing input list of customers, picking their id, and so for that id, hey, what is the room number that has been allotted to, that is this. So we are providing in order to match the given output that we require in the result. Right at the end, we are just outputting the priority queue size, which is so if you observe, so that is the max number of rooms that you would need. Okay, because let's say for customer 1 you have allotted new room, customer 2 has come, you have allotted room number 2, customer 3 you have allotted room number 1. Okay, so so you are actually making use from an existing pool, right? So whatever the priority queue size that remained at the end of your processing is the total number of uh, minimum number of rooms that you would require. So output that and the corresponding room numbers for every customer. Okay, so this once you run it, you can see on the right hand side, if I just omit this for a while, and if you run this, you should see key, hey, I would need 2 rooms, and the order should be 1 1 and 2. Okay, so here the I have given four I have flipped the order, but if you provide the same inputs as you had, I think it should give you the correct results. And if you see, it is 2 1 to 1. And yep, so if you just submit this, and it's accepted. Cool. That's it for this video. Thanks a lot, folks, and uh, have a nice day. Signing off.